But so thanks for coming back after lunch. And two things before I start. So first of all, interrupt me while I'm talking rather than waiting with questions until the end of the talk. And then secondly, I'm really sorry, I'm gonna walk around a lot. I think it's a German thing. I don't know whether you saw our other German speaker yesterday, but I cannot really stand still while talking. So forgive me, camera, I'm sorry. Right, so I'm really excited to give this talk in front of this audience because after we've already heard about it, like new technologies that people are developing, I think all of us in this room are now actually interested how we get these technologies out there into the messy world where all of our assumptions don't hold anymore and get them more widely used. And I think, first of all, I need to justify giving a talk titled like this, because if you talk to people in this community at this conference, or if you look at some of the headlines, privacy seems to be doing great. Everybody wants data privacy as quickly as possible. So, for example, we've heard about Google pioneering this field of developing new privacy-enhancing technologies, offering privacy for machine learning. So you think great, I can have privacy for my machine learning model training. What are you talking about? Then we have large organizations outside the private sector, such as, for example, the US Census Bureau, who are reviewing all their statistical disclosure control techniques because they're wakening up to the new threats that are out there to the citizens' privacy, and they're exploring new techniques such as, for example, differential privacy to defend against these emerging risks. Then recently, Apple joined in. Apple has announced we are going to use differential privacy to gather sensitive data from all the Apple mobile phones, and it's one of the most exciting examples, I think, because everyone who has an iPhone can go into the settings and then privacy, analytics, you scroll down all the reports until you see the ones with differential privacy, and then you actually see differential privacy in the wild with some epsilon value attached to it. And even I have no idea what this epsilon of 4 now gives me in terms of privacy, but it somehow makes me feel better about the world because people are at least trying to do something. However, by now, there are also enough examples of organizations who are trying to use their data, and they've published some kind of data set, and they were using some type of anonymization technique to defend these data sets. And either maybe because the right techniques weren't chosen or the techniques weren't implemented properly, this led to some massive breach of privacy. And I think most of us here will be familiar with all these stories that are out there, and it's going to be more and more stories where organizations were publishing data sets that weren't sufficiently protected and then led to a breach of privacy. So obviously privacy-enhancing technology that were out there didn't prevent this from happening. However, in this talk now, what I actually want to focus on is the organizations which are really afraid of either violating privacy regulations or they're actually really concerned about protecting the privacy of the individual in the data sets that they hold. And thus they're either completely locking down access to the data that they have and not using that data at all, or they still rely on really laborious manual access control and human monitoring to protect the data subject's privacy. And so for these organizations that I want to talk about today, there seems to be this conflict between using the data that they have and protecting the privacy of the data subject. And I think we as a society, we actually have a high interest, or at least we should have a high interest in many of these organizations opening up access to the data that they have. Because we're talking here about data sets that could help to improve our healthcare systems, our educational systems, the way we plan our cities, the way we plan our public transport infrastructure, and all these kind of things where at the moment the access to the data is not there because these organizations see conflict between opening up access and still protecting privacy. And that really shouldn't be the case, because privacy-enhancing technologies have been designed to exactly find this balance between protecting privacy and using the data that you have at scale. So we are asking ourselves, okay, why are there still a lot of organizations which are not Google, Apple, Microsoft, or maybe the US Census Bureau, which are so hesitant to implement privacy-enhancing technologies to do data analytics at scale the right way? So first of all, I want to give you kind of an overview over some of the questions that were raised when we went out and were implementing these technologies and engaged with our customers, trying to convince them to embed privacy into their systems, which, let's say we were facing some challenges while doing that. So this talk is going to be kind of sharing some of our experiences that we had. And I'm going to use differential privacy as an example of one of these technologies, but I would say a lot of the questions that I'm going to raise actually apply to a lot of other privacy-enhancing technologies, such as, for example, homomorphic encryption as well, if you generalize them a bit. So luckily, I do not need to give like a well definition of what differential privacy is, because hopefully all of you have been here for the first talk today, which saves me a lot of work. Thank you. And so differential privacy as a framework has been developed around 15 years ago to answer the industry's need to safely publish aggregate statistics from a sensitive data set where I want to learn something about a group of people, but I want to prevent that an adversary can use these statistics to infer something about an individual in the data set. So that was the goal. That is what the industry was kind of like asking for. So then the differential privacy framework was kind of like developed, combining some kind of techniques that were already out there around like perturbation and the definition of like algorithmic stability. And differential privacy is a property of a data release mechanism, so of an aggregation mechanism or a function that we compute on the data. And what it tells me is that it ensures me that the output of the function or my aggregate query or the statistics that I release does only leak a bounded amount of information about each individual in the data set. We've heard a much more formal definition of differential privacy before, which we actually won't need for the purpose of this talk that much. But let's just like keep in mind, differential privacy was developed as a framework in order to answer this industry need, right? Publish aggregate statistics and give me some type of like quantitative measure of like how much this puts now each individual in the data set at risk if I release this information about the data set. The way differential privacy is like often achieved is through noise addition. So one way of achieving differential privacy for like a count table or something that I want to publish, where I want to count some sensitive attribute in the data set, such as, for example, what was your vote in the Brexit referendum. You might want to keep that a secret. Then you can essentially aggregate like the counts from your data set, and then you add some noise where you draw the noise from a certain nicely defined distribution where you use this parameter epsilon, which is essentially kind of this bound on the information leakage about each individual. You use this epsilon parameter to scale your noise distribution from which you draw your random value that you add to the count. And then you can do your analysis and you say like, okay, I've given some type of privacy to each individual data subject because I guarantee you that the output of the function doesn't change too much if I include your record in the data analysis. And so if noise addition is the way in which we can achieve differential privacy for a mechanism or a function that we compute on the data set, then this noise addition is where the privacy utility trade-off of differential privacy comes from. So each of the privacy enhancing technologies comes with some type of privacy utility trade-off. In the case of differential privacy, it's this trade-off between like the accuracy of the statistics I get out and the privacy that I get for each individual in the data set. For other techniques, such as, for example, encryption, that might be this trade-off between kind of how strong my encryption is and then the kind of communication overhead and the increase in runtime that comes from the size of the ciphertext that I maybe need to send around. Okay, so this is differential privacy, was developed as a framework to answer an industry need. This is the type of privacy utility trade-off that we have to make if we embed privacy into a system using differential privacy. And then it turned out over the years that what the industry was actually asking for was more along the lines of, so I'd like to have a highly flexible query interface onto my relational database where I want the answers to the queries to be like highly accurate, and I have multiple like private entities in my database that all have like correlated private attributes, and I'm going to repeat my analyses over time while the underlying data is changing. That wasn't exactly what was in the initial framework of differential privacy. So luckily, people have then started over the last like 10 or 15 years to like further adopt the differential privacy framework to allow some of these things people were asking for. So that is kind of like one of the streams of work that is like going on, which is kind of looking at, okay, gathering more and more requirements, what are people actually trying to do when they say they want to release aggregate statistics about a data set. But then also on the other hand, it raised this question of like, which of these problems were actually contradicting fundamental theorems about privacy? Such as, for example, it's relatively clear, especially if you're like a statistician or your background is like statistics or information theory, that if you release too much highly accurate information about one data set, at some point you're going to be able to reconstruct this data set fully with high accuracy. So there are just like certain things that people are also asking for, which are just not a good fit for privacy-enhancing technologies. So now we have, on the one hand, a whole list of requirements that we need to fulfill. On the other hand, we also need to distinguish between the cases which are a good fit for the framework and which ones aren't, because they're contradicting fundamental theorems about privacy. Then, so each privacy-enhancing technology, so also like differential privacy, were designed with a certain aspect of privacy in mind, or a certain definition of privacy, and in order to defend against a certain risk with a certain adversary model in mind. And so in the case of differential privacy, there is some type of like worst case assumption about a very powerful adversary that might have any type of background information, and we want to defend against any possible neighboring data sets and protect all of these like possible records and possible records combinations, so that each person in the data set gets some kind of privacy guarantee. And so there are now like theorems around like, okay, when is a reconstruction attack likely to be successful? When is a differencing attack likely to be successful? But how do we now match this with what organizations are actually worried about? Because each organization finds themselves, based on the data that they have, based on the access controls they have around these data sets, in a certain risk scenario. And often people are asking about, okay, I have this like worst case assumption about like what might happen, and differential privacy offers me some very strong protection against this like worst case. But what happens if I want to start making like relaxations of this worst case assumption? What type of guarantee do I now get? How do I translate the type of like risk that I have found in my system into the type of guarantee that I want to get out of the framework? So there's a bit of a problem matching the risk model with which differential privacy comes to the real world risk that organizations are actually worried about. Let's say we live in a really optimistic world where we overcome all of these like more, I would call them technical challenges, where we need to tweak like the differential privacy theorems a bit. We have already heard about like really divergence-based or concentrated differential privacy, which try to kind of like give us some relaxations of the worst case assumption, measure privacy loss within a different way. Say we nail all of this in like the next, 5 years, and what happens then? Are we done then? So let's say one of you has developed some great new privacy mechanism, you've even implemented this mechanism, and now you go to some organizations which you have identified as having exactly the type of problem that you're solving with your mechanism. So you go to them and say like, hey, we offer you really strong privacy protection for your data product. They're probably going to go, oh great, I like hearing that. So what's the level of privacy? So we set to epsilon equals 0.5. I guess that's good because I trust you and you're some type of like privacy expert and I don't know much about privacy, so fine with that. But so what's about my utility? Because this is something I have really strong opinions on, and ultimately I really care about whether I can still do my job after you have added some privacy to the system. Yeah, like don't worry, average distortion is only 3.27, no worries. You probably get another phase like that. So you see that if we now go about and try to convince stakeholders to actually embed privacy into their system, there are some more questions that need answering. So let's look at some of these. So the first questions that organizations are asking themselves at the moment is about what are they required to do? Because it's quite hard to understand like the existing and new regulations and where they actually differ. And to read these regulations is not only hard because they have some complicated terminology. No, it's also hard to understand where they actually set the bar in terms of like what is acceptable risk and what is too much. They have some type of like vague definitions of what privacy is. But if you now take these and you try to translate that into like some type of like roadmap about which type of technologies you will need and what will be the bar that you need to meet in order to say I've done enough to sufficiently protect the privacy of the individual, that's not so clear if you just read these legal texts. So there's the question of what are we required to do from an organizational perspective. Then second, what could we do? So the landscape of privacy-enhancing technologies is growing and has become quite complex. And there are many different people out there who advise you to do many different things. And if you do not have a PhD in privacy, you actually don't have a good overview over what is out there. And then secondly, given you have a certain type of analysis in mind that you want to do on your data, what is now the right technique for doing that? What type of like technology fits with the type of like the data format that you actually need. Then if you've identified what you're required to do and what techniques are out there to like reach this bar that you set yourself, it's not so clear what you should do. Because if the regulations are vague on the requirements, they're certainly vague on whether a certain technology now defends against the risk that you've identified. And as long as there are no good best practice examples out there, everybody's really hesitant to say and make a statement about whether a technology sufficiently reduces the risk that you've identified. So you probably need another PhD to now figure out whether the technology you've identified and implemented has sufficiently reduced the risk. Then every organization, when they're about to like buy a new technology and like embed a new technology into the system, is gonna ask themselves, what do we gain by doing this? And unfortunately, like the industry is still very much used to like measure the value of a technology in dollars and not in some abstract concept like privacy. And you might be able to tell them what they gain in privacy in a future world. But what does that then mean for these organizations in terms of gain in revenue? Will this actually help them doing their job, or will this just like harm them? How much do they currently lose because they have like 10 employees who all need to like do data access control, and the technology would maybe help them reducing this effort? And there are several aspects of this problem, and some of them we cannot really measure because we actually don't have an idea about how much customers care about privacy when they're choosing a service, which will obviously affect like the gain in revenue that a company might get out of embedding privacy enhancing technologies. But one aspect of this problem is certainly that you need a tool to measure the disclosure risk that you have before implementing technology, and then after you've implemented the technology to measure the reduction in risk that you get out of this. So there is like a lack of tools to more clearly measure actually the risk reduction that a certain privacy enhancing technology provides to these organizations. And then lastly, everybody's obviously concerned about what do we lose. So I've quickly talked about the privacy utility trade-off that every technology has. So it is clear that privacy in most cases doesn't come for free. There might be edge cases where privacy is actually an enabler and not like a blocker that is doing you some kind of harm. However, there is certainly something to lose in terms of, for example, with differential privacy, in terms of the accuracy of the statistics that you get out of that. And even though differential privacy comes with some theorems about the accuracy loss, it doesn't really come with a good way or like a more intuitive way of the loss in data utility that you have. And very often an organization has actually some very specific, some use case specific utility measures, and they just want an easy answer to the question of like, will this impact my analytics results too much, where they have some custom definition of what is too much. And it's very hard to go from the accuracy loss that you get from, for example, noise addition to this answer to this question about like the use case specific utility measure. There were no questions so far. No? Okay. There's one. It's good. I need to drink something. Sorry, guys.
So, isn't this like explaining epsilon to the business partner? Isn't this like a usability problem? Like typically, like when people do not understand permissions or like do not understand legal language. There is a usability problem. Here the usability problem is in math, like they're not understanding the math there. So isn't the solution there like a human-computer interaction type of solution where you bring like better explanation, better interface to explain what epsilon is, like by exemplification or by trying that.
So I'm going to try to repeat your question, first of all, for the camera, and then secondly, also to check whether I understood it correctly. So you are asking whether this kind of translation from the parameters that you have in the technology to some understanding of like what the business understands at like risk and what they're interested in, whether this is more of a translation problem or like a user experience type of problem that we need to work on. So partly it is. But I would claim, and people might disagree with me, that even if you get better at, I don't know whether I have my slide here, where you kind of like you take this approach of saying we've heard epsilon is essentially like it's a multiplicative factor, right? Like the way you measure kind of the gain, essentially the gain in confidence, one could say, that the adversary gets from looking at the statistics plus minus your record, and I measure kind of like how much that the adversary can gain in confidence about your individual record if I now include your record into the analysis. And there are all these type of approaches of explaining that better and saying, okay, now imagine the attacker had like a 50% kind of like guess about whether you went to the hospital or not, and after looking at the statistics, worst case this might jump up to like 95%, and this is already something that I don't know if I get in front of a customer. That's the type of like stories that we tell to like explain this better. And yes, that is part of the problem, kind of like better storytelling, I would say, around like what the definition of privacy in the differential privacy guarantee, for example, is. But even that is not enough, because an organization, they really start from the position of, okay, what I'm concerned about is this event. It's a certain privacy harm. Like, I'm afraid of this and that happening. Like, I don't know, I'm some CTO and I'm afraid of getting like front page of the Daily Mail. Like, going from that even to this type of like privacy guarantee that you get from differential privacy, there is such a big gap that I need to be able, like, I don't know, through experience or like other tools or I don't know, user studies to, you know, go all this way from, okay, I'm afraid about a certain event happening, down to what is the scale of my noise that I need to add to the output of my analysis. But one part of the problem is certainly, I think it's like my last slide is about that, is this type of like storytelling where we all need to get better at. Any other questions? Yes.
So so you said a bunch of things about how it might be difficult to communicate technology to people. It feels like there must be good analogies in other areas where the same problems come up. So you work in a nuclear plant, right? You wear a rad meter. No one knows what the right safe levels of radiation are for people. They're not going to sit down and try to figure out if it's this many rads or that many rads. But somehow society has figured out that, okay, we can work with that. We can get everyone on board with, we do a thing and we're not entirely sure why we do it, down to every last detail, but we've agreed that, as long as we're doing it at certain levels that people agree are okay, somehow we're not going to be the ones that fall. Sorry, it feels like there must be other areas where the same fuzziness shows up.
Absolutely agree.
If you're going to talk about them, I apologize.
No, I just love it when people like jump to the last slide of my presentation after like the first half an hour. That's very helpful. No, so I think that's part of it, right? Like if you want to learn reasoning about privacy, the obvious place to start is looking at similar or like related problems, right? Because it's not the first time that like as a society we need to make these decisions, right? Like we tend to treat it as a completely new problem that we only have in the age of big data, and like there are all these like abstract parameters and numbers and we need to attach like values to them. And so yeah, I think I would agree. One approach is really thinking about, okay, what are problems that seem to be very similar, or what are technologies that have faced very similar challenges, and how in the end did we get to like a decision and we agreed on some type of value where we say, okay, this is kind of our tolerance level for exposure to radiation is actually like a good example for that. So yeah, but I think main challenge there is getting the right people into one room, right? Because who should be involved in this when it comes to privacy? Because for radiation, you at least have medical experts. For privacy, who are the privacy experts that like really know enough about all of these things? I think we like collectively we don't have enough experience about what is actually a privacy breach and what isn't. And if we don't have that, like what the medical doctors had, for example, they had some experiments around, or they just from experience, they knew, okay, this is too much, there it becomes harmful. And on top of this number, we're going to add some buffer, some safety buffer, and that's going to be our limit. I think if we can deliver that, then we can probably have this conversation much more effectively. Cool. Right, so I'm going to give you an example of where an organization was actually trying to do exactly that. They were building a system, they were trying to use the data that they had in the right way and use privacy-enhancing technologies to do this type of data analysis in the right way. And we worked together with a telco that was interested in analyzing their location data. And every telco has this type of location data because every time your mobile phone pings the nearest cell tower, you get a rough idea of like where a person is at a certain point in time. And this location data set, together with all the demographic data that a telco has about their customers, that's quite a valuable data set because it enables you to analyze some type of like movement patterns of different demographic groups, where you can do great things like improving traffic flow in public transport and city infrastructure planning and all these kind of things. However, they were a great organization to work with because they really wanted to get privacy right. So they really cared about it. And this is why they were also like alerted by a study that was published about like 5 years ago, where people analyzed the mobile phone trajectories of 1.5 million users in a European country over more than a year. And what they found is that because the way we move is very unique, this makes location data quite high-dimensional sparse, and this increases the risk of re-identification. What this means is that even after you have reduced the spatial temporal granularity of this data, you only need to know about like 4 spatial temporal points of a unique movement trajectory to uniquely identify 95% of all the trajectories of individuals in this data set. So this just like tells you, okay, if I share this micro data, this row level data set, even after I've like hashed the unique identifiers, it's very, very easy to re-identify a person in this data set, knowing where they've been at 4 different points in time. So sharing the microdata just wasn't an option. This is why they decided to take the following approach, where they just like offered an interface onto this location dataset where the user could define some spatiotemporal place marks, and then the interface would aggregate the row level data within this place mark and give you just a count of people in a certain region at a certain point in time. And then you could ask things about this group of people, such as, for example, like where they were coming from. Then you would like get another count, and they've decided to suppress small counts to protect individuals in the data set. So to prevent that an adversary can use this interface to learn something about an individual in the data set. And whereas this is certainly the right approach for extracting insights from high-dimensional sparse data sets, such as location data, that you cannot effectively anonymize, there was still a problem with publishing these raw aggregate statistics. Which is, if I take, for example, I know that Alice entered the building this morning at 10:23 because she was like late to the first lecture, and I know she was the only person entering the building at this time. I now want to find out whether Alice has actually spent the night at home, what she claims, or maybe somewhere else. So the first query I'm going to ask is give me the count of everybody in the building between 8 and 10:22, which gives me a sufficiently large group of people, and tell me the origin of everybody who was in the building at that time. Then I slightly expand my time window of my query, and I ask, okay, give me the origin of everybody in the building between 8 and 10:24, and I know the only difference between these two queries is Alice's data that I've now added to the data set by just like slightly shifting my time window, and in whichever origin place mark I see the count ticking up by 1, I now know this is Alice's origin. This is what we call a differencing attack, so raw aggregates are still vulnerable to this type of differencing attack, which we highlighted them. However, this type of data analytics use case seems to be a great fit for differential privacy. All we want to do is publish some aggregate statistics about the location data sets, essentially count people, and then publish some count statistics about this data set. I'm just interested in like the rough movement patterns of different demographic groups, which I expect to be quite large, so I can add some noise to these like raw counts, and by scaling the noise I can make my trade-off between privacy and utility. So how close are the reported noisy counts to the raw counts? And depending on the amount of noise that I add, I get some privacy for each individual in the data set. There are a lot of benefits of using differential privacy here, which we highlighted, such as you get this nice formal privacy guarantee, which enables you to quantify the privacy loss for each individual data subject. It comes with a quantifiable like accuracy loss. And this last thing was actually a very important point, which is you get some kind of like future-proof guarantees. So kind of however you change your system, however you tweak it, whether now maybe like the granularity of the underlying data is a bit improved because you incorporate some GPS data, that will not change anything about the type of like privacy that you get out of the system. Whereas if you use more classical statistical disclosure control techniques, such as, for example, query set size restriction, you would actually need to do a reanalysis of the whole system, finding every single attack on the system every time you've changed something, which can be quite burdensome. However, there were obviously also a lot of questions that we needed to answer after we we suggested to use differential privacy for this use case, which seemed to be a great fit for differential privacy. Because what we did was kind of like taking this bit like gamified approach of like pointing out where there might be some privacy loss and explain them how in theory this type of like differencing attack on Alice origin, like how that works and why that might happen with the raw aggregate statistics even under small count suppression. However, that's kind of like explaining the privacy risk, but if you now want to convince somebody to add noise to their statistics, so essentially add uncertainty to their analysis, there needs to be a pretty good reason for doing that. And the motivation would be, so the right incentive for doing so would be to take the threat that we've demonstrated, the risk that we've identified, and take that for real and actually be afraid about it. And the only way of getting somebody to actually accept noise, adding noise to their statistics, is to demonstrate that the attack actually works. There needs to be a real risk. And without demonstrating that these attacks are real, it's quite hard to compare what you get in terms of protection out of the classical statistical disclosure control techniques compared to the more formal, stronger differential privacy guarantee. So there was this question about how real are these attacks, how hard are they to implement, how hard is it to get this type of like background information, which is something that is quite hard to assess. Then, yes, they were afraid about the loss in utility because, as I've said, you introduce some type of like uncertainty, and this comes with some like theorems about like the accuracy loss, so counts will be slightly disturbed, but that again, it doesn't give me an answer to this question that they were asking, okay, can I still do my analysis? So here is a list of insights that I'm interested about like preserving, such as like temporal trends in the data, or like counting how long people stayed after a concert, how long they stayed around when the trains were like really full. Will I still be able to do this type of analysis? And then at which point does it start to break down? What is my minimum sample size? What happens with like inconsistencies between queries that might come from like noise addition? What about these things? How harmful will they be for the data utility? Will my user still be happy with the results that I get out of the interface? So it was a bit of a lack of a tool to measure what was the actual loss in data utility, not purely measured by a loss in accuracy. So last, yes, you actually need to find some parameters if you implement something. Like what you need to give to an engineer in order to be able to implement something is a clear specification document which tells you what you expect the system to do and how exactly it works. And so I'm only half joking here with this, like, what is epsilon? Obviously, that was one of the questions. But no, there are a lot of other questions that you start thinking about if you start implementing a system like that. As one of the examples is, for example, right, we know that we add noise at a certain scale to our counts. We thus know that we want kind of a type of minimal sample size in order for the signal to be strong enough not to be washed out by the noise. And to avoid that a user draws false conclusion based on the noise that you've added to the statistics, but actually only picks up the real signal in the data, you would like to apply some query set size restriction where you still suppress statistics about small groups of people to avoid these type of like false conclusions. How do you communicate the uncertainty that you've added? If you combine this with like spatial and temporal aggregation, should be a minimal spatial aggregation area, a minimum temporal window in which you aggregate the data. So there are all these kind of things which need to come together with the type of privacy enhancing technologies that should be the core of the system, where you just need to make some decisions about like implementation details. Questions? No? Right.
Yes, another good question.
That's a question for you. Right. Okay. Let's talk about what, at least from our point of view, is needed to like make this happen, to make privacy enhancing technologies usable without having a PhD in data privacy. So the obvious first thing is overcome the technical challenges that come with it. which are things that people are luckily already working on, right? It's about improving the privacy utility trade-off of all these technologies, which makes it an easier argument to convince somebody that it's not too punishing embedding privacy into their systems. Start thinking about how are we handling data changing over time without too much utility loss. What actually happens if I now have a relational database where it's not so clear how many records each individual has in this data set, so I don't know how much an individual will actually affect the outcome of a query, so I don't know how much noise to add. So there are all these technical challenges which we first of all need to solve in order to have like satisfying answers. Then we need to keep up with innovation. And again, people are working on this, right? But the problem is the following, that as long as the field of data science is growing, there will be new techniques that are used. If you think, for example, about mobile phones, which have become very powerful computers, so now they can be used to do some personalized model training, but all these new techniques always will come with some type of like privacy challenges that need solving. So we just need to keep up with innovation and come up with privacy enhancing or privacy protecting analogs of these new techniques. Then, I think this is a really important point. We need to develop tools that enable us to measure disclosure risk in a more intuitive way, taking into account the definitions of privacy that actually matter to each individual. And I think this is very much related, Frank, to what you've been proposing, that if we have some way of like matching how we talk about risk and like measuring risk to what people expect us to measure risk and like think about privacy, if we then can reason about how much privacy loss you have with, say, a certain epsilon, that will make this conversation so much easier in terms of saying, right, we think as experts this is too much, and more than this it shouldn't go. But then this too much needs to be measuring something that actually society thinks is a real risk and should be considered as a privacy breach. So solving these questions will certainly mean engaging more with customers and businesses and lawyers and regulators and each individual also in this room, because we all have probably differing opinions on what the definition of privacy is. Then again, this is one of the most important things. We need to demonstrate that the attacks that are possible in theory are actually practical in the real world. Because I can reason about reconstruction attacks, I can reason about differencing attacks, and I can explain people how that might work after having analyzed their system, but it's so much more powerful demonstrating that these attacks actually work, and if we have more experience in where to get this background information from, it will give us much better arguments for embedding strong privacy into systems using technologies.
Can you elaborate more on that? So how do we demonstrate that it's practical? Because we write all the time it's practical, and we all the time use auxiliary data. So what is it that we need to push to convince the other side that it's actually practical and I can actually get the data? Because we do.
So I'm not sure whether I agree on we do this all the time. I think it's something that recently we've gotten better at, which is that from the paper, they actually come with an implementation, which is the first step, right? But until very recently, papers were theoretical, and there wasn't even an implementation of like the attack code that people proposed. And then secondly, I think it's about working together with the data holders who actually have real data. Because you've talked about this, right? Like an attack is very data dependent. It very often depends on the specific data set. So if I now start working with like synthetic data set that only like replicate the patterns that I've plugged into it, and then I start to attack these, I've already like in building the attack made a lot of assumptions about like how the data looks like and how much, for example, auxiliary information I will need to attack with. So I think it's just like encouraging data holders and organizations, and there are actually like a lot of government agencies which are like worth talking to, right? Because they have this problem of they actually need to publish the data, and they have high incentives of doing it the right thing. To like go to them and make make them aware of the risks that are there and try to find projects where we can like implement these attacks on some real data sets, and then like try to design defenses which are a bit more generalizable beyond what we found for this type of data set. And so coming back to your question, I think I just wouldn't agree that we've always done that of
No,
actually
I wouldn't say
demonstrating.
always,
I
but
think
like
it's
recently we do this all the time, and I'm asking like, are we
what more
not-
is
we need
needed.
more, like exactly, like what's your feeling when you go to companies and they come to you and they say they don't believe what you wrote on the paper because we believe it's true, and then it's very hard to know how much we walk.
Yeah, I think it mainly needs more of these kind of like engagements where we actually get them as far as taking the risks so seriously that they allow us to experiment with their system and demonstrate them the attack. This is why I know where's Alan? Is he here? This is why I loved his talk, right? Because it's a real system. You can actually go about and like attack this system, just registering as like an advertiser like on the platform. So this is just something they need to take seriously, and there's no reasoning out about like, I don't know, this is very unlikely to happen, so we don't need to care about it. So I think it essentially says we need more of this, and we've only very recently started of doing that.
More logos on the attacks.
Yeah, one moment.
We need more logos on the attacks.
Just keep on doing what you're doing, Camila. You're doing great. Right. Then, together with the tools of measuring disclosure risk, yes, we need to work on these tools of measuring utility and utility laws in a more intuitive way and in a use case specific way. Because an organization, this is like, utility is something they care about, they have strong opinions about, they normally know what type of insights they expect to extract out of the system. So all they want is really like a tool, like a slider between privacy and utility, where I can now tell them, okay, this is your risk scenario. Using this technology with these implementation parameter gets you this far at disclosing the risk. And yes, be careful, this is how much you lose in terms of utility, where I need to phrase this in a way that speaks their language, which is the utility they actually care about preserving. Okay, so we have developed these tools. Then we now need to take on like the most difficult task probably is like of using these tools and saying, okay, this is the things you care about preserving. I'm going to measure how much your utility might be decreased. This is the type of things that you think are at risk. This is the type of like requirements that you have in terms of like reducing the risk. So these are your implementation parameters. And again, I think the only way of like getting there is more collaborations, because each one of us is probably like an expert in like something, and we bring something to the table. Some people in like, I don't know, business analytics might have really good ideas about the tools of like measuring utility. Other people here in this room might have much better ideas about tools to measure disclosure risk. And now talking to the regulators, talking to society, finding a definition of privacy, at some point we should come to this point where we say, okay, this is an acceptable measure of risk, and this is where we set our bar. But I think the only way of getting there is getting the right people together in one room and talking and reasoning about this. Then one thing I actually also don't need to explain this anymore, because we've actually heard about this work this morning as well, is there is some really nice work where people go about and try to find the synergies between privacy and utility, where privacy actually might not do you that much harm, but it actually might help you to achieve exactly what you want to achieve. And so from this Partey work, there's this amazing blog by Nicholas Papineau and Ian Goodfellow about like how privacy for machine learning model training can avoid certain situations where you maybe memorize the training data too much, and then you might lose some generalizability. And so using privacy as an enabler here, you might avoid some of the problems that you run into otherwise. And so I think we all just need to get better looking out for these type of use cases where privacy isn't that harmful, identify them, tackle them first, and then learn about the much harder use cases afterwards. And lastly, this is one of my favorite ones because it's a great lunch topic, or if you go to the pub, you can talk about this. It's this type of like storytelling that you've asked about, which is this like there are a lot of abstract parameters in this space. And so now finding stories about these parameters, explaining what they actually mean, translating them into like some scenarios people might actually care about, finding nice stories, maybe about radiation, maybe around like the evil insurance company which is trying to infer something about you, maybe something along the lines of like Facebook advertisers trying to like discriminate individuals, trying to find these type of like stories which help you to explain what is the actual problem, what do the parameters in the system mean, and how is the technology trying to defend against this risk. Right. So if you ask me, this is what we should do now. This is what all of you should do now, which is aim to make these privacy-enhancing technologies manageable for non-experts, so making them usable without a PhD in data privacy. Translate the abstract parameters into more interpretable ones. Find stories to explain these hard concepts in data privacy, talk to individuals about the expectation of privacy, what should be the right definitions of privacy, talk to lawyers and regulators to learn their language and share your expertise with them, and watch out for these synergies between privacy and utility so that we start tackling actually the right use cases first, where we don't break our legs when we try to implement some of these privacy-enhancing technologies. Thanks for your attention.